Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of exponential regression. This is standard A.9E in the great state of Texas, and we are using item number 21 of the 2021 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have this conservation agency tracking sea turtle population, right, counting the number of sites since 2001, so number of years. We don't have a zero, unfortunately, but we have a pretty stable step, right? 1 year, 2 year, 3 year, 4, 5, 6, 7. So since we have this step, right, we need to find a function that best models this data. So if we wanted to, we could try to graph it, but that really wouldn't help us much. Because what we're looking for is not necessarily a graph. We're looking for something that looks like this. Y equals a times b to the x, right? And so we're looking at this a term, and this is going to be many things, but this is your initial or your starting amount. And this is what you get when x equals 0, because it is the y-intercept. Now, how do we know this is the y-intercept when x equals 0? Well, if I were to plug in 0 right up here, it would be a times b to the 0 power. Anything to the 0 power is simply 1, so it would just be a times 1 or a. Unfortunately, we don't have a 0 right here, so that would be very helpful. If we had a 0, whatever this number is would be my a term. So we don't know. Now, this b term, take a look at this. This is your growth rate. If it is greater than 1, this is your decay rate if it is less than 1. And take a look, from 1 to 2, right, we're going down. But then from 2 to 3, now it's going, back up, right? And then from 3 to 4, it's going back down again. And then it's going up again. So it's fluctuating. It's going down, then it's going down again here. So we're fluctuating. I don't even know whether this is a growth or decay rate. So all things being said, we definitely need our calculators. So let's open up our TI-84 graphing calculators. So first off, we're going to hit our second and 0. We're going to get into that catalog. And since we're going to be using a regression, whether you use quadratic or in this case we're going to use exponential, I also want to make sure your diagnostic is on. So we're going to go ahead and click that. Now we're going to hit that stat button in that second row, and we want to edit because we want to put our lists here. So this first one's going to be pretty easy. We're just going to go 1, 2, 3, 4, 5, 6, 7. This next one, though, we need to make sure we're entering it in correctly. And so this second list is going to be our y-coordinates, or our dependent variables. 40,513. And what we're going to do is we're going to let the calculator do the work. It's going to figure out the best fit for our a term, best fit for our b term, and that's really what we're looking for, is what is our a term and b term so we can put it into that exponential standard form, 27,691. All right, so we double check. We make sure that everything looks good. What we're going to do now is we're going to go back to our stat, but instead of edit, which we've already done, we want to scroll over one. We're going to hit in the calculator tab, and we're going to scroll down here to 0, right? It's exponential regression, since that's what we're dealing with, is the exponential form. And our list 1 is just going to be all the x terms. Our list 2 is going to be that n of x, or the y terms, the dependent variables. Scroll down to calculate. Now, this is all it's going to give us. It's going to give us an a term. So a equals, and it's going to say 46,797 points. Let's round it to the nearest hundredth. And then your b is going to be, it's a slight decay rate, 0.9. I'm going to round it to 0.93, right? And so we look, and obviously we see it right there. That b term, b answer, is going to be the closest thing we have here. But really, it's going to be very difficult to do that by hand. That's where we need to use this exponential regression on our graphing calculator. So our answer here is B.